Hey everyone, Mr. Mitchell here. I hope this video finds you well. Now what we're going to do today is we're going to do a lab. So our investigation today is looking at a scale model of the solar system. Now something that I have a difficult time comprehending is just exactly how big everything in space is. Uh, I think you're probably like me, you get a sense that everything is really big, really far apart, but I want to give you a bit of a scale model of this so you can start to understand it. Now, we do have the universe, and the universe contains everything, and the universe is, I can't even describe how big it is. And the thing that's kind of freaky about that is the universe is expanding. What it's expanding into, I don't know. It's not expanding into anything, it's just getting bigger. So that's kind of freaky on its own. But we're going to zoom in today, or not zoom in, I guess zoom in. We're going to zoom into our solar system. So our solar system is everything that orbits or revolves around our star, which is the sun. So we're going to make a scale model, or you're going to make a scale model of the solar system, just so you can see the relative spacing of the planets and just how big the solar system is. So I'm going to use this little video to go through this with you. I'm going to post a second video going over how to do some of the math, and then it's going to be up to you. Now, as far as posting this, I think what we're going to do is we'll make this due on Friday. So if you can submit it to me by Friday, but don't submit it to me right away. I'm going to get you to try to submit it to me in the portfolio section of Edsby, and I'll also be sending out instructions on how to do that, and we'll give that a go. We'll see how that works for us. So don't email it to me, don't private message it to me, don't put in the post office box and have it mailed to me. We'll try that portfolio section, and I'll give you instructions. So this will be due on Friday. Of course, I guess you can post it or put it in the portfolio anytime before that. So our equipment and materials, hopefully you have a calculator, I'm sure you do on your phone. A tape measure. It says here pictures of objects in the solar system. When we do this in class, I usually have pictures of each planet. If you just want to write out each planet on a small piece of paper on a cue card, you could just use that. So first of all, the radius of the solar system. So if you can imagine the sun being at the center of a circle and everything that revolves around the sun inside a big circle, that circle from the sun out to the edge of it is 50 AU. Now if you recall, an AU is an astronomical unit. It's the unit that we measure within a solar system. In the universe we use light years, and that's how far it takes light to travel in 1 year. That's much too big of a unit to use within our solar system. So within our solar system we use the AU, and the distance from the sun to the earth we have categorized as 1 AU, 1 astronomical unit, and we based everything else on that. So if another planet is 3 AUs, that tells us that it's 3 times the distance from the sun that the earth is. If it's a half AU, that tells us it's halfway between the sun and earth. So the earth becomes, with the value of 1, becomes our frame of reference, and it allows us to understand how far everything else is away from a comparative value. So the radius is 100 AU, or I guess all the way across our solar system would be the diameter, or 100 AU. But the 50 AU is the distance from the sun to the farthest dwarf planets that we have observed at this point. There might be more out there. We just don't have the technology to see them yet. In a scale model that you're going to produce, 50 centimeters will be 1 AU. So in real life, if it's 1 AU from the sun to the earth, on the model that you're going to create, is going to be 50 centimeters from the sun to the picture of the earth, or for the earth card that you have created. So that's going to be our scale. 50 centimeters in real life, or sorry, in our model, is equal to 1 AU, or astronomical unit, in real life. So this means that the sun is placed at one edge of the model, then the farthest dwarf planet will be 20 meters away. And in order to do this, you're going to use this formula right here. If it looks a little bit confusing, in the other video that I posted, I'll show you how to use it. So your job is then to complete this table. And as I mentioned, my other videos show you how to do that. You're going to take these actual distances, you're going to convert them into a centimeter distance on the model. And because centimeters is a little bit too small to use for this model, we're then going to convert it a second time into meters. So the sun is no distance from itself. And these values right here are all the distance from the sun. So the Earth is 1 AU away from the sun. We can see here Mercury is about 4/10 of the way between the sun and the Earth. And we can see Pluto is 40 times further away from the sun than the Earth is. Now, Pluto is a dwarf planet. When I was your age, it was a planet, but the definition of a planet got reworked and it became a dwarf planet. It lost its planet card. In order to be a planet, you have to be the biggest thing in your atmosphere or in your orbit. And at one point, Pluto's orbit and Neptune's orbit cross each other. And because they cross each other, Neptune, being much bigger than Pluto, is now the biggest thing in Pluto's orbit. So Pluto is no longer a planet. Big question I ever get, will Neptune and Pluto ever collide? The answer is no. So your job is to do this table. You are going to go outside and you are going to create a model of a solar system. Hopefully you can find a time sometime this week when it's not raining and get that done. And then walk your model, paying attention to the relative distance of all the planets from each other and from the sun. And then you are going to, as question 2 here says, you're going to use the information found in table 2 on page 319 of your textbook. I will post 319 of your textbook, and so you'll have that for reference as well. So your job is to complete this lab, complete the questions, whether you're typing them up or writing them up. You're either going to send a file to me, or you can take a picture with your phone of your write-up and send that to me as well. And once again, I will be posting some instructions on how to do that within the portfolio section of ESPE. So I think that's everything. If you do have a question, please don't hesitate to contact me. Have a great day, everyone.